Hey everybody! So what I'm going to do for you right now is I'm going to work through the problem that we started in class today that was about the soccer ball being kicked off of a hill. This is my dog Cole right here. He's wanting to be in this really badly. I'm going to try to keep him off of the whiteboard as much as I can. So first thing I'm going to do is I'm going to diagram the situation that we were given. In the problem, it said that there was a soccer ball that was being kicked off of a hill with a certain initial velocity in the horizontal direction, and this is what we're going to be trying to find in the problem. The rest of the problem went on to tell us that this hill is 22 meters tall, and that the soccer ball, when it came down and landed about 35 meters away from where it had begun at the top of the hill. So this is a pretty complete diagram. This has everything that we need to know in it. We know the height, where the ball started from, the distance that it went, and now we need to find the initial velocity in the x direction. To organize this information better so that we can make sense of it when we start calculating, I'm going to turn this diagram into a chart that will show each of our variables in the x direction and in the y direction. The possible variables in a projectile motion problem like this are distance, time, acceleration, initial velocity, and final velocity. Cool. Yeah. The first thing I'm going to do right here is I'm going to start filling this chart in with information that we already know. Without even looking at this diagram, there are certain things that I can fill in this table with only the information that we're being given a horizontal projectile. Those things are the acceleration in both the x and y directions. Cole, quiet. Okay. We know that these two are true. We know that the y acceleration is negative 9.8 and that the x acceleration is 0 because of the definition of a projectile. And the definition of a projectile, it's an object that is in the air being affected only by gravity. Because it's being affected only by gravity, we know that our acceleration must be the acceleration of gravity, because that is acting in a vertical direction, and we know that the acceleration in the x direction is 0, because gravity has no effect on the horizontal direction, only on the vertical. So we know that both of these things are true. Later on in the problem, because we know that both of these things are true, we also know that whatever we find to be our initial velocity will be the same as final in the x direction, since our acceleration is 0. One more thing that I can fill in is that because this is a horizontal projectile, meaning that none of the initial velocity is in the vertical direction, I know that my initial velocity for y is going to be 0 meters per second. And then also because of that, we know that our y distance will be negative. An object that's projected only horizontally can't go anywhere but down due to gravity. So we know that the distance is going to be negative because we are considering the downward direction our negative direction. So that's everything that I can fill in without having ever seen the problem. Now I can fill in the numbers that I was given at the beginning of the problem. Cole, no kisses. Okay, so the first thing I'm going to put in is this 22 meters right here. This is my y distance because it's vertical. So I'm going to put this in over here with y. I had already indicated that it would end up being negative, and now that's just ensuring that I don't end up with accidentally putting in a positive number. I had already indicated that I was going to make sure my y was negative. The other number that I was given was this 35 meters. That's the x distance, being that it's given in a horizontal direction. And that's it. That's all I know. So compared to the first example problem that we did in class today, we really have fairly little information given to us. I want to be able to find this initial x velocity, but on the x side right now, I only have 2 variables. Looking at the equations that we're going to be using, I know that I have to have 3 variables on one side, either x or y, before I can make one of these equations work. So what it is now it's to the phase where this is just a puzzle. I see that I don't have enough information on x, so I know I have to use y to find something that can help me out over here. The only possible things that I could find on the y side are time and final velocity. Final velocity isn't going to help me a whole lot. It's not going to give us any information that we can use for x, but time will. The important thing to remember about time is that it is the same for both x and y. We can really consider time to be one number. Time can't be divided into an x and a y. Time is just time. So if I can find the time in the y direction, then I can use that to give more information for x to be able to find the initial x velocity. So that's what I'm going to do. My goal right now is my first step is going to be to find time and then use that time to find my initial x velocity. To find time, I have to choose one of these four equations. Now, we've already talked about how we don't have a final velocity in the y direction. So I can't use any of these equations that include a final velocity, or I won't have enough, I won't know enough variables. So that means the first equation, the third equation, and the fourth equation are all out. The only equation that could possibly work is equation number 2, because it's the only one that doesn't require us to have the final velocity. So what I'm going to do right now, I'm going to use this second equation specifically for the y side. It's important to remember that we can't choose one of these equations and pick and choose from the horizontal or the vertical direction. We have to choose one. So I'm choosing to use equation number 2 for the vertical direction only. To indicate that, when I write out the equation, I'm going to add a y subscript next to each of the variables to make sure that I remember to only use the y side. The exception to that is time. I don't need to put a y with time because, like we said, time is going to be the same for x and y. So now all I'm going to do is plug in my values from my chart that I've made up here. My y distance is negative 22 meters. My initial y velocity is 0 meters per second. My y acceleration is negative 9.8 meters per second squared. Now what I have to do is go through and simplify this equation. Lucky for us, this part here is all going to end up being 0. 0 times anything is just 0. So I'm going to forget about this part of the equation, and I'm going to be able to only focus on 1/2 at squared, which means I only have one unknown variable to have to simplify. To simplify this even more, I know that 1/2 of negative 9.8 is negative 4.9. Now to get t on its own, I need to get rid of what's next to it, and that's this negative 4.9. In order to get rid of something that's multiplied, I'm going to divide. Anything I do on one side, I'm going to do on the other side. On this side, it cancels, so we're left with just t squared. On this side, we have negative 22 meters divided by negative 4.9 meters per second squared, and that's going to give us 4.49 seconds squared. Now t still isn't resolved all the way. We still have it squared, so I'm going to take the square root of both sides so that I'm left with time being equal to 2.12 seconds. Now it's easy right here to stop and feel like you've completed the problem, circle it and move on, but this is only one step. Now what I need to do is plug the time that I found back up into my chart so I can continue solving. So I'm going to add this 2.12 seconds to my chart. Next thing we need to do is go ahead and find the initial x velocity. Remember that the only reason we found time was to make it so that we had enough variables on the x side to find what we're looking for. Now we have 3 known variables, one that we want to find, so we can use one of these equations to do so. Once again, final velocity is the thing that we don't know and don't want to know. So we're still going to use the second equation since it's the only one that doesn't require us to have final velocity. I'm going to write that equation, but this time my subscript will be x because I'm no longer using the y side. I'm now worried about the horizontal component of this problem. So this time we're going to have dx equals the initial x velocity, that's what we're going to solve for, times time, plus 1/2 of the x acceleration times the time squared. Let's plug in our numbers and do our last step. Our x distance is 35 meters. The initial x velocity is what we're trying to find. The time, which we just found, is 2.12 seconds, plus 1/2 of 0, because that's our acceleration, times the time squared. This whole part will simplify down to 0. So what we're going to be left with is 35 meters equals the initial x velocity times 2.12 seconds. Now to get the velocity on its own, I will divide by what it's being multiplied with so that that will cancel. And of course I do the same thing on the other side. So we're left with the answer that the initial x velocity is equal to what will come out to 16.51 meters per second. And that is our final answer.